Okay, so first off, let's kind of we can touch on the whole wizard stuff that you were just asking about, because it kind of applies because you ultimately need to put properties in for things, and that ultimately carries down to the drawings or on the drawing level. So let's. Does everybody still have access to that assembly that we were playing with last week or on Monday? Yeah, the engine thing. The reason it doesn't matter what assembly. If you have any assembly in general, it will work. So once you get this open, the next thing you're going to want to do is go down to Tools and Add-ins. And then you're going to want to make sure that Toolbox, Library, and Toolbox Utilities here are checked. On the active side. You don't need to have them checked on the startup side. But
Tools and this is add-ins.
yep, it'll be down at the bottom.
Alright, after add-ins,
Then you'll get this menu that pops up.
okay.
And then just check on the left-hand side under Toolbox Library and Toolbox Utilities. And then go ahead and hit OK after that. What's that?
How'd you give you the menu?
Tools, add-ins. So then over here on the right hand side under the little house, there's this tab called the Design Library. We're going to go ahead and click that. And you'll see this. Yours might not look identical to mine, but you will find this toolbox drop down right here. So you can go ahead and click the little arrow. And then again, yours is going to look a little bit different than mine because I have mine kind of cleaned up to only show the things that I use on a daily basis, but you're going to have a whole list of other stuff in there. But you should find something along the lines that says ANSI inch or ANSI metric, I believe. So I'm just going to go under inch stainless. And then under bolts and screws, and I'm just going to go under a socket head screw. You guys finding that stuff? Okay. And then the cool thing about this is I can go now and I'm just going to grab it. So there's socket heads, flat heads, and button heads. And you might have some additional options in yours as well because you have the full database set up in yours still. So the cool thing is you can just come over here, click and drag off. And then you're going to get this little menu over here that pops up. And again, mine might look slightly different than yours. But the important thing is here, you can go through and you can select any size that you want of a fastener all the way up to a 4-inch bolt. So we don't need to be quite that ridiculous. We'll just go to a half 13.
And so that's a knock that you're talking about, there's no threads, it's just a
Yep.
cylinder, but
Yep, but it represents the geometry that you need for putting in fasteners. So that's kind of the high level of the toolbox.
so for our DLAs and like final projects and stuff, instead of going to McMaster trying to pull some bolt through and like doing whatever, just figure out what size and everything it is, use the whole wizard, and then just take the part number and then put
Populated in the BOM.
it. Oh, okay.
Yep.
That'll make life
Yep. And I'm just going to stick this in there, and then you can tell that this is a toolbox part by the way that it shows up in your design tree. So if we go back over to our design tree over here, we can see that we have this little fastener symbol next to part itself. And that just shows you that it's a toolbox part. And the really nice thing about this is that you're like, oh, okay, now I realize I need a 1/2 inch shorter bolt. Well, I can right click on here, edit my toolbox component, and I can just go down here and change the length. And then that updates. And like I mentioned before, in my case, once you enter the properties, so this now, oops. So these are all pre-configured McMaster part numbers that I've used in the past, and that's why they have McMaster numbers on them. Does that make sense? So I went through and I've entered the part number down here. And again, yours might look a little different, but we can get it set up for you so that it looks similar, so that it works like this. But you essentially enter a part number, and then you can add it to your database, and then you have all these predefined sizes. So now if I change the size here to 0.875, well, in this case, there's no part number set up for it yet.
Oh, okay, so you could just, if you saved a bunch of the stuff, you could just throw that in and it would automatically pull it for you.
Yes.
Yeah, I'm gonna do the partner.
Bob?
You're gonna do an assembly drawing, now if that include that screw in assembly drawing, is it gonna come through a cylinder shaft like that, or as opposed to a screw or bolt? Features?
It's gonna, I guess I don't understand your question.
Let's say you're doing an instruction manual for a customer,
Mm-hmm.
and you wanted to show a variety of screw sizes, like an IKEA product.
Mm-hmm.
If you use that toolbox part, is it gonna have threads on it when it comes through in an assembly?
So you can set it up so it shows threads, but the reason I don't have that shown is because generally speaking, the assemblies that I'm working on have thousands of parts in them and tens of thousands of screws potentially. So
No, I understand that. But
so yes, you can set it up so it shows the threads, or you can set it up so it's not showing the threads.
I mean, is it more beneficial if you want to show the threads than just to take the?
No, I'd still do it this way. I'd still use the toolbox for that. I have it turned off in my toolbox right now, so I'm not sure that I can even show you right this minute how to make it show the threads. Yeah, so thread display, see it, there's
Okay.
simplified, cosmetic, and then actual threads. So I have the cosmetic and actual turned off, and that's just like the standard that we use at my work, and that's why it's not even an option, because it literally just increases file size and it doesn't make
Sure.
any sense to have. So, but if you wanted to, yes, like, and if you look at yours right now and you go to this thread display option, you'll probably see the other options, and then you can click through those and see. I'm not sure if one of you guys want to test that theory, but I'm pretty sure yours should still be able to be selected.
Schematic, the actual.
You might end up having a customer that absolutely, for some reason, wants every last bit of detail in there, and if you want to show them the threads, then, or if they want you to show them the threads, then that's the option that you would select under
Yeah.
thread display. Okay. So any other questions on the toolbox stuff before we get into the datum surfaces and symbols? Okay, so I'm gonna go ahead and close this. Let's go ahead and make a new part. And let's just go ahead and make like a base plate. Just gonna make it 24 by 12 by 1 inch thick. So maybe actually before I continue, does anybody have any questions on the reading? Or any of the symbol stuff that you read through? Did anything not make sense? Anything you want more clarity on?
flatness thing, I felt like it was made decent amount of sense, but I think there was something about the datum feature not equal to datum or something. Weird thing. Let's see if I can pull up the email.
Yeah, let's see here.
I breezed through it and figured it probably wasn't that big of a deal, but I think it's had something to do with the flatness. You know, it's different.
Right. So maybe I should just start out by kind of talking through like maybe the more commonly used symbols that I've used. Now I'm sure they all have a place and they're all appropriate to be used in certain situations, but a majority of what I'm using on a day-to-day basis is flatness, obviously your datum. Profile of a surface is generally used when you have something with, or at least when I've used it, has been if I have something with like a lot of contours or something that's maybe like something along the lines of like a mold, and I'm gonna say on my drawing itself like CAD model for profile, and then I can call out the profile to be within 2,000ths or whatever I desire of the actual model itself. Basically, I use that where I have a lot of varying geometry, and then I want that to be maintained. Perpendicularity and parallelism are very commonly used in frames, because obviously when you're designing your frame, you want it to be a square and not a parallelogram. And I think, yeah, those are going to be like the 3 or 4 main ones that we're going to use, and I guess the ones that we'll go over today. The other ones are good to have an understanding of what they are, but like I said, unless you're in a very specific type of manufacturing where those types of things are used, I don't see a ton of value in, I guess, trying to use them if they're not needed. Okay, so let's do this, and then let's maybe
What was the thickness of that?
1 inch, but whatever, it doesn't matter. So then let's maybe draw just a box on here. Oops. Yes, let's do another one of these over here. Actually, let me get out of this. Edit this sketch. Something I'm not sure if I've shown you guys or not yet, but one cool thing you can do with dimensions is you can write equations right within the modifying screen. So I can say, if I want this distance right here to be the same as this distance right here, I can literally type in equals and then click that dimension. And then it's going to give me my little equation symbol, so you know it's a driven dimension, so I can go in later then and say I want this to be 4 inches, and then that'll automatically change. Okay. So I'm going to point out one thing about flatness here, which is, I mean, some other features or symbols also apply in this case, but let's see here. This phrase, this sentence or statement right here. So it's a common symbol that references how flat a surface is regardless of any other datum's features. So essentially what that's saying is you want this surface flat, and it's not relating it to any other surface. So if you think about, like, if the top surface was like wavy, right? You can still call that out to be flat without reference to anything else. Whereas, like, if you're calling out something to be parallel, you need to call it out with respect to another surface, right? Or perpendicular, you need to call it out with respect to another surface. So let's go ahead now, once you have a part that looks something of this nature, let's go ahead and make a drawing. It's going to make you save it. I'm just going to go ahead and use a C size. Throw this in there. And throw these two in there. Save my drawing. Oops. Okay, so I'm going to go ahead now and point your attention to these two buttons here that we're going to be using. So we have our datum feature and our geometric tolerance. So first of all, let's go ahead and define our datum. So under datum feature here, we can kind of do it one of two ways. The easiest way, I think, is just to click the surface that you want to be your datum surface, or the edge. Go ahead and click datum feature, and then it's going to automatically snap it to whatever it is that you clicked. And let's maybe throw another datum feature off of this. And maybe a third. Actually, no, we won't put a third one. We won't need it. Okay, so now we have our two datum surfaces that we're going to start using some of our symbols to define the geometry of. So under geometric tolerance is where we're going to find all of our symbols. So I'm going to go ahead and throw a flatness in to this top surface here. So I'm going to click that surface. I'm going to do geometric tolerance and select flatness. And I'm just going to say 0.002. Go ahead and click OK. My symbol will pop up. And what I'm essentially saying is I want this top surface not to deviate any more than 0.002 of an inch. Anybody know how they would measure that? Mm-hmm.
with a dial indicator, whatever, when they move it across.
Mm-hmm.
Pretty
Yep.
sure it's a dial indicator.
Yep. Dial indicator or some sort of probe. It would just come
Yeah,
down.
dial indicator, yeah.
Yep. A dial indicator would be probably the easiest way to do it, though. They could put the dial indicator right on the machine head, and then just run the table back and forth, and they could watch the dial and see how much it deviates. Generally speaking, any ground plate that you're going to get is going to be flat within 5/10 or 5/10,000ths of an inch. So,
Not
Gen-
too much to worry about.
what's that?
Not really too much to worry about.
Mm-mm.
Well, I guess depending on the material. and what it is.
Yeah, absolutely, depending on the material. If you have a piece of flame cut plate or something that, you know what I mean, that's going to be wavier than all hell, then. Yep. So, that would be an example of where you could use a flatness callout. Now, we could have it flat, but this thing could still end up being a parallelogram. So, what we could also do is we can throw a parallelism symbol in here with respect to our datum A. So, if we go under geometric tolerance, symbol, parallel, and let's say this is 5/1000ths, but parallel with respect to what? Parallel with respect to B obviously wouldn't make sense because it's perpendicular to that surface. So if we hit the tab button, we'll tab over to this primary section, and then we can type in, oops, RA. Go ahead and hit OK. And now we're calling this surface parallel to A within 5/1000ths of an inch.
How often do you need to use them?
For this type of stuff, not super often.
Lego blocks on a plate, but I mean,
When it comes to a,
you,
um,
do you use,
these I would say almost on every single frame, because you're going to be calling out parallelism between like your leveling pads that your feet mount to the top surface, or if you have any other weldments that get welded on top of like your base plate or any other weldments that come off of your frame. So say you have just a square frame, and then you want an arm coming off of that square frame. So you're going to want to call that perpendicular to some extent, right? So it's not just welded on there crooked this way, crooked this way. So, and it's easiest to, I guess, measure that through a parallel or through a perpendicular or parallel symbol, because then you can like use a square essentially to measure that. You can throw a square on it and you can see very quickly, is that perpendicular or is it flat or is it parallel? Does that make sense?
yeah, but how often are designs, do you design things that are involved that need that kind of,
Pretty often. I mean, like I said, any machine or anything that I would design that I'd have a frame would have some sort of perpendicular or parallel and flatness callouts on it. So like, let me pause this here and I'll show you guys another example here of like a frame or something here in a minute where this kind of stuff is used. So then maybe one more we could throw on here would just be a perpendicularity callout. So geometric tolerance, perpendicular, 10,000s with respect to A. Let's see if there's anything else in here that could throw on there. Yeah. Probably good at that point. Let me see now if I can find. I think I have something. Oops. There we go. So here we go. Maybe it would help to put some context to this. I don't know if I'm going to be able to show this or not. If I don't have it on my desktop, I won't. But no. There we go. It's the E. Actually, I'll just open up this whole thing, whatever. So here, let's focus on this frame down here. So we have these pads down here that are our wheels or our casters are essentially face mounted to through these spacers. And then we have these leveling feet, or hydraulic leveling feet, that get mounted on these outside frame pieces here, these outside weld members. So if we look at this part, we know that we're going to want this surface that this whole upper assembly mounts to be flat and parallel to the ground, essentially, which is going to be in contact with the wheels. So if we look at our drawing, we create our datum surface to be at where the face that our wheels mount to, and then we call out a parallelism to this top surface that the whole machine mounts to, essentially. And what that's going to do is it's going to assure us that our machine, like deck plate on the machine, is parallel to essentially the ground that it's sitting on. Otherwise, you could essentially have your machine sitting like this.
I guess I just figured some of it was more intuitive, and I suppose
Right.
unless you take for granted,
Right.
the better off your design's gonna end up.
Exactly. It's a cover your ass type of thing.
Yeah.
I mean, the more definition, the more clarity you can put to something, then the better chance you have of getting it back exactly how you want it. Now, granted, sometimes you put these things on drawings and you get it back, and it's like, oh, this just isn't a print. And then when it comes back down to it, then you hold the machine shop accountable, rather than if you didn't put that on there and then now your machine's sitting like this. Well, now whose fault is that? You didn't put any sort of tolerance or dimension on that to constrain that. So, like I said, it's a kind of a CYA type of a thing, but
Yeah, well, that's kind of what my original question was like, I mean.
So like if you understand how to use it, there's definitely value in
Take
using it.
advantage of it.
Yes, absolutely. And then this here is just a flatness call out on the surface that these hydraulic legs mount to. So I think that's all that is really specified in here.
It just seems to me that 5,000 on a cart
Sure.
is.
Right. And again, it just comes down to
What it's used for.
what it's used for, what you're designing. So we got about 3 minutes left. Does anybody have any additional questions about, I guess, any of this stuff?
we're gonna be in shape like, dude.
Pretty often.
Of course, you're gonna have to say dude, then say, here you go, and you went, oh my god.
Right. Yeah, so I mean that's another thing too, like a lot of times like those guys obviously know a lot more about the manufacturing side of it and how they're going to make it, and they might look at something and be like, I don't know how I'm going to hit this. Like, is this really important? And then you can kind of go back sometimes and say, oh well, maybe it is super important, and there's a different way that you can maybe weld this frame together in order to achieve it. But I mean, yeah, I mean that happens very frequently where I'll get machine shop guys coming back and asking me like, how were you expecting to do this? And sometimes it's just a matter of explaining what your thought process was to them as far as how you would machine it, because maybe it was different than what they were thinking. And then sometimes you're like, they'll come back and they'll have a way better way of doing it, and you're like, oh yeah, I can change this one thing really easily and save them 3 hours of machining.
Sure.
So,
Do you get a lot of contradictory things from people in the machine shop? Where somebody's like, oh, this is way too much detail, I can't figure it out, and then somebody else is like, I need more detail. I mean, I assume each person is kind of different, but like,
Sure.
depending on, I don't know if you guys just work with your own machine shop or like other ones or whatnot.
so yes and no. I mean, some people can obviously be harder to work with than others. I mean, in any case, in any situation, but we do a lot of like, there's a lot of people that look at these drawings, like they go through like 2 or 3 checks in engineering to make sure that they are manufacturable before they actually hit the machine shop floor.
Oh.
I mean, again, yeah, we still get that sometimes in the end, but generally speaking, most of those things are mitigated and caught up front in engineering before the drawings even hit the floor. And I think that's probably true in most places. Maybe if you got to like a really small place or a small shop or something, and it was just like one designer type of a thing, you wouldn't have those extra means of verification before things hit the floor. But I think generally speaking on bigger equipment and stuff, you have multiple people going through it and looking at it and verifying it before you hit the floor, because obviously when those things happen, you're causing more pain down the line, whereas if you were to spend the extra time up front, it's a much smoother flow of just the process from start to finish.
Sometimes what looks good on paper doesn't look good in reality, and
Right.
sometimes an extra set of eyes on it would be like, yeah.
Yeah, absolutely.
Alex, am I right in remembering that a lot of the parts that you're doing, or a lot of the things that you're doing here are kind of quantity one or two?
Yes. Yep.
So
this
maybe you need longer to think about this, but how would you can you generalize a statement in that? How are the suggestions you're making different for really high quantity productions versus 1 or 2 quantity productions, right? The perspective that you're responding to is
Yes.
kind of doing things at a quantity of 1 or 2. Some other people might be doing quantities of hundreds of thousands. So where do you see the biggest change in how things would or should be done? In other words, what comments are you responding to in which the answer is kind of correct for 1 or 2 quantity production?
Yeah.
But not really the right answer for quantity 10,000 production.
So I don't have a lot of experience in that sense. So
Yep.
I guess I don't know if I have a great answer for it, but I would think almost if you're going to be producing 100,000 of something, you're going to want to make damn sure that it's essentially perfect before it hits the manufacturing floor. Because if it's not, then you're going to have a lot more, I guess, consequences in the end of trying to fix things if you have 10,000 things that you need to fix versus if you have 1 or 2 things that you need to fix. So in terms of, I guess, the pushback or the back and forth that you would get from the manufacturing floor, I'm not sure that you would have that with a high quantity build. Like, I think with like a high quantity build type of a thing, you would essentially be able to send whatever you're making to anywhere, even like maybe China or something, and then just expect to get it back. So you maybe lose that, you don't get that feedback when you're dealing with like high volume stuff. I don't know if that totally answers your question, Jake, or
Yeah,
not.
I mean, I don't think there is really an answer, but I just, maybe sometimes it might be worth just thinking about how,
Sure.
the answer is different for a mass quantity piece versus a
Right.
one-off piece, which is what I know that you do.
Yep. So.
Yeah, because what's the trade-off with the high production? You want to keep your costs as low as possible, and the high production one-off in the prototype, you're paying big money for it and you know it, so it better be
Right.
right.
Right, and if you think about,
Based on the results of that, you can probably say, all right, we don't need 5 thou here, we can get away with 20 thou.
right,
And still operates 99.9% of the time.
right, and like with the 1 and 2 off builds, like you have a pretty similar cost between manufacturing hours wise or hours versus like engineering time. Whereas if you're manufacturing a million of something, you have a huge portion of your costs in the actual manufacturing and maybe less into the engineering. So,
Yeah.
so that spending extra time in the engineering may be much more trivial at that point.
Yeah.
Or it would be much more, not trivial, sorry, it would be much more valuable spending the time in engineering versus if you are just making 1 or 2 things where you can kind of modify and change things on the fly if you need
Fixed
to.
cost that's easily absorbed in quantity.
Right. So, with that, I think we're done.